Hello everyone, good afternoon. Dear authors and invited guests, welcome to Technical Session 4C. I am Harsh Soni, moderator of this session. On behalf of Global Knowledge Research Foundation and Knowledge Chamber of Commerce and Industries, it's my great pleasure to welcome you all to the 7th International Conference on ICT for Sustainable and Development through Zoom. I hope this session, I hope you will all enjoy the session. And there's a special note for the presenters that you will be given 8 minutes for the presentation 7 minutes for the on 7 minutes I will be raising general environment. There's 2 minutes for the question and answer also. And there's another request for the presenters that you will please stay connected with us until the closing remarks. And if you have any query or any suggestions or any updates, you can please write it to me in the chat box. And before we get started, I would like to introduce you all to the chair for the session. Professor Geeta Navle. Dr. Geeta Navle is working as a professor and also she is the head of department in computer engineering and in Singar Institute of Technology and Science, Pune, Maharashtra. She has more than 23 years of experience in teaching. She has 30 plus international journals, publications, and presented in more than 20 international and national conferences. Welcome, ma'am. Now I would like to start with the papers. Our first presenter is Manju Balakrishna Pillai, and she is presenting on nuclei segmentation using UNET with efficient NET V2L encoder. The presenter you may be started.
Okay, so now I can start, right?
Yes.
Okay. Let me share my. If my screen is visible?
Yes, it is.
Okay. Good afternoon, all. So this is my paper, and it's regarding the nuclei segmentation using UNET with efficient net V2L as encoder. Myself, Manju PB from Amartha Vishwavidyapeetham, Kerala, Kollam. And this project is done under the guidance of Dr. Jyotisha Nair, my guide. And coming to the topic, the nuclear segmentation. So nuclear segmentation of histopathology images is very important for designing a system for cancer diagnosis and prognosis. So here it comes the importance of computational histopathology. Computational histopathology means for counting normal or cancer cells, we can segment the regions of interest, we can recognize the tissue structures, classification of these cancers, grading cancers, etc. all comes under computational histopathology. So because of this various shapes, colors, and of different stains of the cells, it's very difficult to get a generalized solution on in this area. So here in my work, I am using UNET with EfficientNet V2L as encoder, would use as a model architecture for automatic nuclei segmentation. And coming to the literature review, as I said before, color variation in histopathology images and various structures of nuclei are two major problems in this area. And there are many methods are designed to address specific types of cell images like breast, cervical, blood, and prostate. And in different types of cell images, structure of the cells and their corresponding gray level distributions vary significantly. So a aforementioned method can be directly employed to segment all types of nucleus. And there are many related works in this area like machine learning based segmentation, k-means clustering, deep learning based algorithms, then UNET++, redesigning skip connections to exploit multi-scale features in image segmentation, then Naylor's FCN to find nuclei in the background. It all comes with some drawbacks too, like for machine learning based segmentation, they are limited by their tedious and time consuming feature engineering. Then k-means clustering types, like they are extremely sensitive to the parameter settings, and the user has to specify the k, and it's effective for one or specific types only. Then the Singh model, Verma model all have large amount of running time, complexity, etc. Then talking about the research gap in this area, automatic segmentation of cell nucleus has received great attention over last decade, and it still remains a challenging task, like splitting of heavily clustered nucleus, absorption of stains, poor segmentation of nucleus, then under and over segmentation, then time consuming and not so cost effective works. So coming to my methodology, first is the data set preparation, then I'm pre-processing the data, then the data is transferring to a modified unit and interpretation of model accuracy. So why I choose unit? Unit has an advantages of getting better performance as compared to other segmentation models. So in addition to getting a finer result, the encoder part of the unit is replaced by EfficientNet V2L, followed with a post processing, which gives an 87.3% on ImageNet dataset. This is the dataset I used here, monoseg dataset. It refers to multi-organ nucleus segmentation. And the original data set has a total of nearly 21,623 annotated nuclei borders in 40 photos of 7 organs, and each with a resolution of 1000 into 1000 pixels. The first step is pre-processing. Pre-processing means like in the first phase of pre-processing, color normalization. That is, I used Wahedane method. Method proposed by Wahedane is used here for normalization, and the stain density maps are used with stain color with respect to a target picture to create a structure keeping color normalization and sparse stain separation method. So these are the results obtained after color normalization. Then we are doing the patching operation here, that is splitting of this normalized images into equivalent patches with a step size of like 256 into 256 into 3. So the images are in RGB form with values of pixels ranging from 0 to 255, and normalization procedure is used to bring these pixel values to 0 to 1. So after this splitting, we are doing the data set split into like with a validation split of size 20%. So this is the before and after patching images. Then the proposed architecture here, the encoder portion of the unit is replaced with EfficientNet V2L architecture. So this is the proposed architecture. So in the pre-processing stage, as I said before, first is the patching operation. Then each characteristics maps the number of channels, resolution, and bandwidth. So that as the depth in the encoder continuously grows, the images of size of this 256 into 256 into 3 are first it is downsampling, downscaling, then followed with an upscaling. Then the decoder session, the images are upscaled to the size of 256 into 256 into 1. So the upscaling layers are then concatenated by the encoder session of the network for getting spatial features of the images. Then when EfficientNet V2 as encoder, so here MB convolution and fused MB convolution layer representation. That will explain in the following slide. That is the MB convolution module with the depth-wise convolution, and the fused MB convolution module without depth-wise convolution is considered as the building block of EfficientNet V2. And the training-aware neural architecture search and scaling is used in EfficientNet architectures to jointly optimize training speed and parameter efficiency. Due to this, EfficientNet V2 model trains much faster than EfficientNet V1, a state-of-the-art models, while being up to 6.8 smaller. Then talking about the model parameters, learning rate, loss function, metrics, and optimizer is used here, and validation metrics are intersection over union and dice coefficient. And hybrid loss is utilized for loss function, that is a combination of focal loss and dice loss. Then these are the representation of sequence of post-process carried out. That is also with different steps, like first it is dilation operation. So for classification of nuclei from the background. Then after getting a sure background, distance transform operation is carried out to get sure regions of nuclei. Then subtraction option is carried out for getting the border pixels of segmented image. And in the final stage, watershed operation is used to get the instant segmentation method. And finally, the number of nuclei in image was computed by total length of the data frame, which means which contains the nuclei dimensions got after watershed operation. Then these are the model results, the metrics and loss plot of proposed model. Then these are the performance comparison of models on monoseg dataset with the UNet, LinkNet, SegNet, ENet, and UNet with EfficientNet V2L. These are the model predictions with its instant segmented images. And these are the validation of model with other methods like UNet with EfficientNet V2L, simple UNet, UNet with EfficientNet V2S, UNet with EfficientNet V2M, unit with efficient at V1, B1, etc. These are the intersection of a union of proposed model with different. And coming to the conclusion, the proposed model resulted in good overall segmentation performance on the monoseg dataset, considered with an average decade index of 0.85 with dissimilarity value of 0.91. And compared with other deep learning methods, proposed models produced more excellent results than mask RCNN unit ensemble unit with ResNet 50, ResNet 101, etc. Then integration of proposed model with watershed for post-processing has resulted in a good instance segmentation and estimation of size of nucleus cells. And to enhance an network to improve the generalization and prevent from being overfitting. And these are the references. Thank you.
Hello, Manju. Am
Yes.
I audible?
Yes, ma'am.
Yes. Is the data set designed by you, or you have taken online from online any reference?
Hello, ma'am.
Yes. Am I audible?
Yeah. Yeah, your voice was breaking that time.
Okay.
Now it's okay.
Yes. Is the data set designed by you?
No, ma'am.
So from where you have taken?
It's from the site only, ma'am.
Which site?
Monosig. I think I referenced it here.
Okay.
The
Okay.
papers with code, I guess.
Which one? Okay, let it be fine.
Related papers, and in that, from that link, I have taken this monosig data.
Okay. The pre-processing method which you have used, right?
Yes.
Why did you choose that? Have you tried any other methods and then you have come down to this conclusion that you should use this one?
Yeah, first it was like a simple color normalization, and I tried like when we started the project. And with the stains, but that time the performance was like as the data set is limited by the number, so only this color normalization, I think that won't work. So we just combined it to a stain normalization and do this patching, so that will be getting enough number of data for the training and all.
Okay, and what was that, you can say, something missing in other methods so that you got the good results?
No, first, like when we started the project, I didn't apply this patching operation. We were just doing the color normalization and trying to work with that. But as the data set is limited by the number, so my guide also suggested to do some kind of patching so that we'll be getting an enough number of data.
So you mean to say that other methods were have not used, you can say, patching?
Pardon, ma'am?
Okay, other methods or other authors with which you have validated your result, compared your results, so they were not using the patching?
No, they were also using the patching in different papers. There were many methods, but I didn't apply patching at the beginning. Later only I added this. That's what I.
Okay. Okay. Thank you, ma'am. Thank you.
Okay. Okay.
Thank you for your great presentation. Now, moving for our next presentation, Plane Pechabala, and is presenting on designing an experimental setup for digital twins in modern manufacturing, a case study using a water bottling plant. Dear presenter, you may please start your presentation.
Okay, let me try and share my screen. Can you see my screen now?
Yes, it is visible.
Sorry?
Yes, it will be good.
Okay, let me start then.
Okay.
Greetings, everyone. My name is Pilani Shabalala. I'm from the Central University of Technology, Free State in South Africa. And the title of my paper is Designing an Experimental Setup for Digital Twins in Modern Manufacturing, a case study using the water bottling plant. So here we have the presentation table of contents. So the fourth industrial revolution era has brought about major changes in the manufacturing industry, and these changes were made to improve productivity and product efficiency. One noticeable change is the shift from the traditional mass production to customized production, as customers today expect faster deliveries and personalized products. Make to stock and make to order are the two modes of productions that are used worldwide in the manufacturing industry to satisfy the demands of the current market. MTS systems being those that are suitable for large, stable, and continuous orders. However, this is a traditional way of manufacturing and there is less variety in the products. So unlike MTS, in MTO systems, the production orders are not predictable and production can only initiate, production only initiate after a customer's order is placed and received. So MTO is one of the pillars of Industry 4.0 known as smart manufacturing. Smart manufacturing is a term that is used worldwide when describing the future of production. It was developed in the emerging fourth industrial revolution to transform the manufacturing industry in order to satisfy the demands of the current market. So the challenges in manufacturing currently are global competition, high demands in product variety, shorter lead times, and a need for a virtual system that can predict the design and production flaws before manufacturing. So smart manufacturing addresses these challenges by merging the physical and the digital world in creating what is called a digital twin. So the digital twin concept was introduced in the 1960s at a NASA Apollo program where two identical spacecrafts were built with the one on Earth simulating and predicting the conditions of the one in space. So Michael Greaves of the University of Michigan then introduced the concept to the manufacturing industry in 2003. And then after that, we've seen digital twins getting more and more interest from different companies across the globe. So digital twins aim to support digital transformation as they offer a number of advantages such as reduced cost, optimized production, faster deliveries, and therefore making them a possible solution for several problems in Industry 4.0. So a digital twin can be defined as a virtual system that is designed to simulate, monitor, optimize, and predict the conditions of a real-world system based on the historical data and the live data from the sensors. So now let's talk about digital shadows, which we have seen becoming more and more important since the advent of the fourth industrial revolution, as systems keep on getting more and more complex due to the increase in the quantity of information. So digital shadows always refer to the physical system and makes decisions based on the data that comes from the different elements of the system. And one advantage of digital shadow is that they can save or keep in their memory the historical data of the system that the system itself might have lost and cleared. So here I have a comparison between digital twins and digital shadows. So both of these models are leaders in digital transformation. They utilize data from the physical system to create a virtual model. However, that is where their similarity ends. So the data flow and the level of integration is what separates these two models. So in digital twins, we have a data flow that is two-way, which means a change in the state of a physical product will result to a automatic change in the virtual product as well, and vice versa. However, in digital shadows, a change in the state of a physical product will result to a change in the state of a virtual product, but not the other way around. So digital twins use both the historical data and the live data from the sensors, while digital shadow only uses the historical data. So digital twins being able to use the live data means that we can say digital twins are able or are capable of taking a real input, while digital shadows, they can only use the historical data or the dummy data as input. So digital twins being able to take real input, it gives them the ability to be able to predict future faults and predict a number of what if scenarios, which is a feature that digital shadows currently don't have. So as from the title, this water bottling, with this paper uses the case study of a water bottling plant at the Central University of Technology in South Africa. So, and since one of the customer demands today is customized products, the water bottling plant is designed to produce a variety of water bottles at the same time. So to be specific, the 500 and the 330 ml bottles. So this plant is made of 3 smart manufacturing units, also known as SMU, and the entire production is driven by PLCs, the programmable logic controllers. So we have SMU1, which is the filling station, and then after the bottle is filled, it moves to our second SMU, which is the capping station. And then we have the third SMU, which is the packaging station. So here I've attached a mini video of how this plant actually operates in real life. So as we can see, the bottle is in the first SMU. And then the PLC triggers the pump and then the filling starts. And as soon as this bottle is done being filled, it will then move on to our second SMU, which is the capping station. So the capping station uses this festonumetic arm to cap these bottles. And unfortunately, the third SMU is still under construction. So the video doesn't have the third SMU, but the bottle goes to the third SMU after this. So here I have the proposed experimental setup for creating a digital twin for this water bottling plant. If you can see on this picture, we have the top view and the front view of this water bottling plant. You can see all these SMUs that I've already spoken about. And if you can look close, you can see I've labeled and named all the IoT sensors that I want to integrate to this water bottling plant. So these IoT sensors will help the digital twin acquire or obtain the real-time data or the live data from this water bottling plant during operation. So the IoT sensors will take this data from the water bottling plant, this live data from the water bottling plant, send it to thingspeak.com, which is a cloud server, and then from thingspeak.com, the data will then be sent to the digital twin, which will be a model created on a software called MATLAB and Simulink. So conclusion and future work, a digital shader was actually previously created for this water bottling plant, and it focused on the following 4 key aspects, which is the water level, the number of filled bottles, the number of kept bottles, and the production efficiency. So as I've mentioned on a previous slide, the proposed experimental setup. So as part of future work, a digital twin will be created for the same water bottling plant, focusing on the same 4 key aspects that the digital shadow focused on. And the results of this digital twin will then be compared with the results of the digital shadow to see if there are any significant variations regarding the bottlenecks and the cycle time of this water bottling plant. So it is hypothesized that the live data will further improve the efficiency of this water bottling plant. Yes, so that was it. Thank you very much.
Hello.
Hello.
Yes, no questions from my side.
Okay, thank you very much, ma'am.
Yeah.
Thank you, your presenter, for the great presentation.
Thank you very much.
I would like to introduce our new presenter, Srinidhi Bajaj, and she's presenting on real-time driver drowsiness detection using open variable.
Yeah, good morning, sir. Today Srinidhi won't be able to present, so I am Harshita, but I will be presenting on her behalf.
Harshita Bhatt. Okay.
Harshita Bhatt, yeah.
Okay. Yeah, you can please start your presentation.
Sorry?
You may please start your presentation.
Okay. I cannot share the screen right
Now you can.
now. Okay. Is my screen visible?
Yes, it is.
Okay. So our final year BTech project topic was a real-time driver assistance system for the drowsiness detection. With the help of our guide, we were able to successfully build our model. So this is the agenda for the today's presentation. Then the problem statement, it is to develop a driver assistance and the alert system which detects the drowsiness state of the driver in real time and alerts the user effectively. So the major cause of accident was due to the drivers falling drowsy. So to reduce those number of accidents, we aim to develop an application for the drowsiness detection system by monitoring the eyes of the driver and sounding an alarm when they are detected to be drowsy. So the technologies which were used was the OpenCV high cascade classifier, the Perclose algorithm for the detection of the facial landmarks, and the eye closure. So the major objectives for an to build our model effectively was, first of all, it should be a real-time monitoring system so that we can ensure the accuracy. Secondly, it should be non-intrusive so such that it doesn't distract the driver. The third thing was it should be easily available and affordable to the user, and also it should be user friendly. And the system was able to work in various lighting conditions as well. So the proposed system, in this case, the Android phone or the app was placed in front of the driver to record the facial landmarks using the high cascade classifier, which is a library in the OpenCV. So after detecting those facial landmarks, it tries to calculate the left and the right eye closure. And after that, there will be a threshold value which will be set such that it can indicate that the driver is drowsy and it notifies with the alarm sound. So the software requirements were the Android Studio, which was built on the Windows operating system. The technology which was used was OpenCV, and the data, there was also registered user database, right? So we used Firebase over there, and the hardware requirement was only the Android phone. Now coming on to the technology, so OpenCV was an open source computer vision library which was designed for image processing, which is used to perform tasks like face detection, object tracking, landmark detection, etc. So this OpenCV supports the hard cascade, which calculates the different features like edge, lines, etc. in the image. Now moving on to the design of the Android application. So the driver first tries to log in. If the author is authorized, then it will go to the further stage. If not, the unauthorized user has to register first, then log in. After logging in, the camera will actually start and it will capture the image in real time, and it will try to analyze the status of the eye, whether the eye is open or closed. So if the eyes are completely closed for a particular time period, so it will beep with an alarm sound. Otherwise, it will continuously analyze the status of the eye. So this was the initial implementation which I explained before. So after logging in, basically it will display the credential of the driver, and it will try to track the location as well. Where is the driver driving and kind of things like that. So as I told you that it will capture on the live video streaming. So it will be done with the help of the high cascade classifier, and these images were before converted into the grayscale images on the region of interest. So now to recognize, the next step was to recognize and locate the facial landmarks through the high cascade algorithm. So it was a training method or a pre-trained model which was read using a load method, and this method was used to detect the face and the eyes in the image as you can show, as it is shown below. The facial landmarks have been marked over here, and this cascade classifier is created, and there were necessary XML files that were loaded using the same method. So the list of the XML files are over here, which were required. And then using the Perclose algorithm to detect the eye closure. So basically over here, the eye aspect ratio was computed by taking the facial landmark points which were done before using the DLab library. And this eye aspect ratio is used to check whether the eye is open or closed to determine the status of the driver, whether it is drowsy or not. As you can see in the diagram, it is the eye landmarks from the day library. There were 6 coordinates in which, as you can see the formula as well, over here the numerator is the vertical distance between the upper and the lower eyelids, and the denominator is the horizontal distance between the both upper and the lower eyelids. So the threshold which I was talking about earlier, that is set to 0.25 to detect whether the driver is drowsy or not. If it exceeds it, then it will give the alarm sound. And so over here also in the flowchart, it has been there displayed. So this is the demonstration. And this is for different lightning condition. So we were able to fulfill the major objectives of the project, and by the accuracy, by the very pretty good accuracy we got by detecting it, so the system was able to work in different daylight conditions as well. So the accuracy of the eye detection was 95.8 and the accuracy of drowsiness detection was 98%. So thank you so much.
Okay, Harshita.
Yes, ma'am.
Yeah. I think many people have implemented the same system. You might have seen, or you might have studied. I don't know. So if you have studied, how your system is different from others? What is innovative thing that you have added into that? Hello.
Yes, ma'am. Ma'am, in this we have tried to build a system which doesn't interact with the driver over here. As you have seen that many projects require the sensors and all which have been used, which actually reads the heart rate of anything like that.
Same. Right now, whatever you have shown, that has been already implemented. So how it is different? Okay, let it be. Did you test your system live?
Yeah. This was the live recording of the live one only.
Yeah, that, but it was sitting in the room, no, but the actual live testing.
No,
Have you
the
performed?
actual live testing we didn't do.
Okay,
No, actually while driving we didn't perform it.
Okay, you should go for it.
Yes, ma'am, we'll definitely go for that.
Yes. Thank you so much. Thank you.
You're welcome, ma'am.
Thank you, ma'am, for the great presentation. Now I will invite our next presenter, Anjana S, and she is presenting on employee onboarding automation.
Yes, so good afternoon.
Good afternoon, ma'am.
Yeah, so can you stop screen sharing so that
Yes, please.
so good afternoon to one and all present here. Myself, Anjana, is currently pursuing final year computer science and business systems at Rajlakshmi Engineering College. And today I'm going to present a paper titled on employee onboarding automation. So we all have been part of different firms or organizations for many years. And there is one thing that we go back and think about it, that is the first time when you onboard. There are a lot of different processes that are being taken place by different companies on different methodologies, for example. And they are not such efficient in automating this whole process. Although they have automated systems like mail to send out mails, give an automatic reply to the queries that they respond, or a live chatbot, it is not all such integrated as a whole. So RPA is called as robotic process automation, which will help us to solve this problem. So it will help us to scale and efficiently build bots so that we can reduce this manual, predictive, and repetitive task. So this paper concentrates about a RE framework, which is called Robotic Enterprise Framework, where you can get the details and scale up your project really quickly so that many of the clients on your organization can use it rather than just creating a bot and saving it on your local drive. So the project aims at building a framework which will fetch all the details that you have uploaded for the company and automatically reads those details and fill those on your legacy web application systems that help you to store the employees' detail on your database using an automated tool called UiPath. So the main idea is to reduce the manual work or by fetching those important details from the documents without you typing and having erroneous errors on it. As I said, the need for the proposed system is there are different semi-automated systems that have been part of this onboarding automation for a long time. And our main goal is to create an efficient one-stop solution so that the productivity of humans is really increased and they go for a job that is matching their skill set. And it takes less time to execute and you can have multiple people at a time going for this system and automating the whole process. The advantages of the proposed system are it is highly scalable, it is fast and efficient. As I said, it can eradicate all those manual processes that involves checking, that involves query processing, that involves escalating the particular ticket to a higher authority in order to solve a query and so on. And here, in order to read the documents, we use OCR as well as indexing so that there won't be any errors that comes into the place. And it is a customized framework since we are the website that has been built is on our own. Companies can integrate their own website and own database ERP systems in order to get the details out. As there have been literature surveys performed on a lot of different papers, and two such papers are about an RPA in the world of corporate consideration, which efficiently or primarily concentrates on hiring, selection, and onboarding. And second one is having an eradication of physical persons taking interviews rather than a virtual computer taking interviews and screening and all such things. And from this literature survey, it has been proven that these kind of systems being efficient and plausible in terms of getting into the HR system, and also you get better results and better productivity in terms of the firm's return of investment or in terms of financial abilities. The main objective of the project is to concentrate on hiring rather than just the post process that involves on it. And Our main aim is to combine all those workflow systems that are in and put it into a single automated system. And tools like RP has been trending particularly. So if you have a system that matches with the next gen technology or part of industry 4.0, it's going to give an higher edge or a competitive advantage in terms of your firm's ability to gather so many data and process it in less time. So this is the architecture that is involved. So the bot is built on UiPath Studio, which is monitored and run through the UiPath orchestrator. And through the orchestrator is linked to different third-party apps that are in, so that the website that we use can be accessed really quickly, because their APIs will be uploaded on that. And once from the orchestrator you execute, there are two types of robot which can be performed. Either you can perform unattended or attended. In terms of our system, it is going to be attended, since we need a human trigger to start all of those processes and work on it. The RE framework's structure, which is robotic enterprise framework, which will have a built-in business exception handling. So on the initial init is called, which will have 4 stages basically. One is initialization state, transaction state, process state, and end process. Initialization state is where you get all the details, that is all the files and folders that you are generating out of every employee. And in the get transaction, you will read all those process, you will process, and end the process, you will get successfully been entering into the database and storing their details. And to be added on with that, not only just storing, it will fetch a new employee ID and mail ID, which is customized according to your organization, so that there is no hassle in creating unique mail IDs, passwords, default, and all other things. The system requirements are really simple. The system Windows 10 with 8 GB RAM is enough. Or if you are using or going to run on an Android space, you need to have an Android system that is, kind of up to date. And in terms of running this bot, it is advised to have UiPath extensions installed, or having a UiPath cloud account is enough. So, since it's now going to be published as a package, even if you want to run it, having a UiPath account is somewhat easier to run this process. So the functional system is, as I said, RE framework consists of init process, init transaction process, and the backend system is going to take care of all the storages and cloud details that are present. And this is the table design, concentrating on, in terms of, as I said, it's going to fetch you employee ID as well as mail ID. You're going to have details such as their bank accounts, their Aadhaar numbers, their phone numbers, their current, first name and last name, and so many things. So this is the basic website that has been created just for understanding this project's usability. So this website application is done using HTML, CSS, and JS, and it is stored on a SQL database, where you can go type your personal details, and it is going to fetch your employee ID and a mail ID, which is going to be sequenced, and it's not going to repeat for every employee after a particular cycle. And this is the RE framework design that is represented on the right hand side. So we'll have a start and end session, initialization, and after every system exception that occurs, it's going to take a screenshot and store all of those details. And how we are going to implement it is, the first step is you are going to collect the data, which is using read PDF. And since the offer letter and payroll can be of any formats, let's say PDF and Word, first we are going to collect and scan those. Then, since, for example, I'm going to use the particular website, that is the website that I've shown before, again and again for different employees, having a file which represents the link will help us to reduce the redundancy of workflow. So we will have a config and exception file handling that is done. So every exception that is occurred, you will have a mail ID that has been assigned on the config file. So you can get the details and put it into it, rather than just creating a workflow again and again saying, if the exception occurs on the particular state, do this and do that. And this website is deployed on Firebase, and orchestrator is for the bot, and Studio is where we built, and UiPath test suite we have used to test the data. So this is the workflow that has been implemented and tested. So as you could see, the process finished in 3 minutes for analyzing 15 files and putting into that website. So if we could do this for 10 files under 3 minutes, let's just say how efficient it would be on a larger scale. So on testing, what we did was we implemented this on our small college placement department, where we have 5 to 6 employees who are onboarded new, and we uploaded their folder formats and all other things on particular folder and gave, and it has been not 100% accurate, but it has been precise, and the details that has been entered is fairly good in terms of real-time implementation. And we have modified those errors and made it a good system which is going to be published as a package on UiPath soon. So the conclusion is this kind of automation helps the company to focus on their key aspects. And if we can bring 100 employees and having great talents, and on post hiring them, it's a cumbersome task for the HR team to concentrate on that particularly. So this will help them to reduce those tasks and concentrate more on hiring new talents. And the main advantage, as I said, it takes less than 2 minutes for in terms of 5 to 6 documents, and in 30 minutes you can process over 150 plus documents, and also have a secure endpoint, because UiPath system is as well have a security architecture, and combining with the legacy systems and infrastructure security present on the firm, it is going to be a whole secured endpoint for us to share the data, and also for the bot to process it. And in the future, we can also do a background checking based on resumes. We can also ask them to upload their resumes, and we can put it on that folder and analyze the links, whether it has been, they have rightly did it, or what are their projects and all about. And along with that, we can make it to be unattended, so that it runs on a scheduled thing automatically. Whenever a new mail comes, it can automatically read that and process and put it all. And we can use this for document understanding and newer products that has been developed. And these are the references. And this paper consists of myself as a primary author, and Bhuneshwaran as my second author, Swarna Shanti D as my third author, and Dr. Priya Vijay. And thank you. That's it from my side. And if there are any queries, I'm happy to answer.
Hello, Anjana.
Yes, ma'am.
The system which you have developed, is it only for recruiting and selection process?
As of now, yes, ma'am.
Okay. So what do you think such type of methods are not present in the market?
Actually, it has been present recently on Virtues as hiring. After they hire, they mostly configure their Gmail or Outlook on such a way that they can process this. But in terms of query resolution, or if they sign the document wrongly, and most of the IT companies give those tasks to us as an employee itself to enter the data correctly.
Yes.
So, which is also a tedious task in terms of having a secure system. So.
Yeah, that the next question comes to is that how it is secure?
Yes, ma'am. So in UiPath has already have a secured endpoint system between the UiPath Studio and Orchestrator. So the data present, or the things that we store on Orchestrator, basically remains secure. Once it gets transferred to our own web application systems that have been built, then only the question of security comes, and it's up to the company's infrastructure in terms of that security of data transferring primarily. And since most of these are dealing with files and folders, there are no internet connection that is currently particularly required. So if your system on your local is secure, then it's almost, and there is no such thing where you can sniff on the internet and get the data. So in terms of that, it's secure.
Okay, thank you. Thank you.
Thank you.
Thank you, ma'am, for your great presentation. I would like to introduce our next presenter, Manu Rajan Nair, and he's presenting on Prophet's tool for prediction of Prophet Loki in bacterial genomes. I think he's not available. So, our next presenter is Mukhalasi, and he's presenting on a comparison of transaction fees for various data types and data sizes of blockchain smart contracts on a selection of blockchain platforms. Dear author, you may please start the presentation.
Morning, everyone. May I share my screen?
Yes.
Are you able to see my screen?
Yes.
Okay, sorry about that. Okay, my name is Lucky Mukalusi from South Africa. Today I'll be discussing a comparison of transaction fees for various data types and data sciences of blockchain smart contracts on a selection of blockchain platforms. I'll go through the background and explain what is blockchain smart contracts, the factors influencing the selection of blockchain platforms, and then a comparison of transaction fee for various data types and data sciences, and then the conclusion and future work. So what is blockchain? So blockchain is a decentralized system utilizing many computers around the world. Each computer is called a node. Each node can communicate with each other, enabling a consensus. Each node stores a copy of all the data records available on the blockchain. Data is stored as blocks which are chained together to make a public ledger. Code is then stored as a in smart contracts, which are immutable programs that runs on the blockchain. So blockchain is a write-only distributed database, which its transactions are trackable, irreversible, and can only be added and not edited or removed. So blockchain principles are basically security, transparency, and traceability. Traceability and data provenance in supply chain process flow begins at the origin of every ingredient. Processing, product, packing, and to the last mile of the product distribution. So provenance is basically defined as the place of origin or the earliest known history, which is tamper-proof, and its integrity across the entire supply chain can be verified. Blockchain smart contracts promote collaboration and heighten the increase of automated production processes in smart manufacturing environments. Currently, one of the most popular global identification protocol standard is Global Standard 1. Therefore, data provenance pertaining to the supply chain process flow from obtaining raw materials, manufacturing, and shipping of the order is then incorporated into the blockchain smart contract, as you can see on the diagram on a figure above. However, there are contributing factors for the selection of a blockchain smart blockchain platform for incorporating data provenance into smart contract. These factors include maturity, centralized or decentralized operation, throughput, transaction fees, to name a few. Blockchain platform high transaction fees have negative financial impact associated with the deployment or interaction of smart contracts. So this paper is written based on the research done in comparing transaction fees for various data types and data sciences of blockchain smart contracts on a selection of blockchain platforms. There are various data types. I think my slides are going, sorry about that. There are various data types from static to dynamic, which are and are not limited to integer, unassigned integer, string, and byte. So for this paper, the focus is only on the byte array, which is fixed, and the byte dynamic, which is by default is a string. So the comparison of blockchain platforms is limited to the following: to Ethereum, and then Ethereum 2, which is only coming out, the main one is coming out September, and then Tron and Polygon. As you can see on table 1, I've actually converted my surname to a byte32 as an example. So all the data sets that I'm testing actually been converted to byte32. So with the following testing strategy, for the first test 1, I took the byte32 of data size 256 against a data type string of data size 256. And then for the second test, I increased the payload to 768 bits, and then against the string of the same bits of 768, and then increased for test 3 to 2304 bits against the string of the same bits. And then the results indicate that with respect to test 1, storing data type string of 256 into Ethereum blockchain, the transactions are high as per the literature review, as you see on table 7 there. With respect to test number 2, storing data type of 768 into Ethereum 2, Tron, and Polygon, the transaction fees are low. With respect to test number 3, storing data type string of 2304 bits, Ethereum 2, Tron, and Polygon platforms transactions are low. This proves that blockchain virtual machines operate with 256 bits. In conclusion, key findings indicate that it is expensive to store data type string than storing a byte32 of the same data size for incorporating data provenance into blockchain smart contracts. However, the drawback of this research study is that test networks transaction fees are not considered, since transactions are free and do not experience network congestions like the public networks. So future experiments are proposed and will be conducted on the main network to incorporate data provenance into a modern manufacturing supply chain, with a case study of a water bottling plant that is with Central University of Technology. Thank you. Is there any questions?
Hello.
Hello?
Yeah, Lucky.
Yes.
Am I audible? Yes.
Yes, I can hear you.
Yeah. You have used Ethereum, then ETH, TRX, and Matic, right?
Yes, ma'am.
So why you haven't given thought for others?
I can give thought for others like Binance, which have smart contracts, but because of the study, I only focus only on this 4. But I can more than increase the other platforms and see what are the transaction fees on various other blockchain platforms.
Okay, why you can say why all these 4? How they are different from wallets, or they are same as wallets?
All of them except for Tron, Ethereum and Ethereum 2 and Polygon. Actually, Polygon is actually a layer 2 of Ethereum. So their wallets are exactly the same, except for Tron, it's using a slightly different wallet.
So other wallets are also there, Coinbase, or you can say MetaMask.
I'm using MetaMask.
Okay, you are using MetaMask.
Yes.
So if I create account using MetaMask, can I remove again that account if I have created it?
On MetaMask. Ma'am, you mean on MetaMask? Yes, you can create an account on MetaMask and actually remove it.
Okay. Okay. Thank you. Thank you.
Okay, no problem. Thank you very much.
Thank you for the good presentation.
Thank you very much.
I would like to introduce our next presenter, Alisha Vinod, and she's presenting on modulation techniques for visible light communications, comparative study of BPFA, and 16 QAM. She's available? Okay, so moving to our next presenter, Renuka Deolalkar, and she's presenting on music source separation with deep convolutional neural network. Dear presenter, you may please start your presentation.
Yes, I'm available. So should I share my screen?
Yes.
Is my screen visible? Okay. Hello everyone, my name is Renuka Devradikar. So I'm presenting this presentation on music source separation with deep convolution neural network. This is the outline of my presentation. It consists of abstract, introduction, background literature, comparative analysis, methodology, conclusion, references. Abstract. Audio source separation is the way in which separation of the sound origin from the audio site is done. So the music origin partition is very essential for various applications. The application of musical origin partition is singing voice removal. These applications also include karaoke and remixing. In this paper, the music separation to understand the tune of each instrument is performed so that artists could learn quickly. Earlier researchers focused on the short time Fourier transform method in which the phase information is discarded. In this paper, the paper focuses on CNN technique in which music voice separation can definitely achieve considerable improvement in separation quality. The execution of a data piece is made up of three instruments, the voice, drum, and bass. Other instruments are also included. This will differ from song to song. The idea is differentiated along with a multi-layer perceptron generating significant results. Also notable advancement in handling time is observed. Introduction. Music origin participants represent a method by which we can separate a mixture into separate distinct sources. Like speech separation involves splitting the mixed signal into the individuals that it primarily came from. It is called as the cocktail party problem. The mixed music can contain background noise, music noise from other speakers, or even all of the above. All music separation begins with defining the desired music sources to be isolated. This source is mentioned as the target source. A musical source means a musical instrument. It may be like the guitar, whose origin we want to separate from the whole mix. In actual definition, musical sources can be simply stated as having similar characteristics that we've used to separate from a group of musical instruments. So like this, so a music basically consists of music of various instruments. So we will separate it into different ways. So like the sound of guitar and all, we will separate in individual. For example, we can mention that in the singing origin partition, our target is basically to split the main voice from the background voice. In more simple words, this definition can also be expressed as splitting the pitched from the percussive ones. In recent days, singing voice partition is used in many fields. The karaoke system uses a partition along with the vocal track for mixing. The objective is to receive a multi-channel model. The method is equally considered as the primary step for lyrics and singer identification. Monaural audio source separation methods have captured the attention of many researchers. This technique of non-negative matrix cleavage has been leading in the field. The methods are very successful. They have huge handling time and are also difficult to adjust in actual applications. The CNN method has been shown to be useful in image processing for performing functions like image super resolution, semantic segmentation of images, in image clarification. CNN input is taken as a two-dimensional angle of an element across the spatial dimensions and also used as the input neurons. This is done to become aware of the localized characteristics. Such as a two-dimensional is executed in the presented model. This is achieved using the short-time Fourier transform in this method. It does not have symmetry across both the assets, but it contains local symmetry. For this reason, filters in CNNs are adaptive to STFP representation. The architecture will be performed on the DSD100 dataset. Firstly, dissociation of the sources is done and then form a mixture, and they contrast the results with multi-layer perception architecture. Although the method is very efficient, it's some disadvantages of it consist of because it functions as a max pool. It requires large data to process and train the neural network. So these drawbacks can be improved in future work by storing information on the exact position on the region. So it can be accompanied further by using the hereditary representation. The background literature over the past few years, different strategies has been proposed. Different researchers use different methods and different parameters in this paper. The researchers takes the basics of the previous and accordingly generate a new. So there's the few. First is the basic technique to partition the periodic audio from the non-periodic that holds the 2DFT, that is two directional Fourier transform, in which the dataset DSD100 was used. The DSD100 consists of 100 multiple track recordings in which the source to distortion ratio, like SDR, source to interference ratio, and source to artifact ratio, like these are the parameters which has been compared in this experiment. The second discuss the idea of the speaker voice loss of target, the method of prolonged mislaying of the voice filter by the two methods. The data sets is of 100. Also, the 10 speakers were randomly selected. It also consists of SDR, PSU as the parameters which has been used. This third one is the idea of the complex ratio masking for music origin extraction was presented. It is a dense unit method which gives the real and imaginary values of the STFP. In this also the parameters are compared like the SDR, SIR, SAR, that is SIR is the image to spatial distortion ratio. The limitation in the method was like its mislaying is representation in very complex form, and the data set constructed was DSD100. This method talked about music partition using deep regression neural network. A multi-level DNN branch was also employed as a nonlinear regression function. A speech enhancement for the singing voice partition was used. The task was implemented after the training. So the dataset was DSD100. This idea was put forward the method of monoreal audio partition implemented by deep convolution neural network. This experimented presented learn about the localized characteristics. In this method, the dissociation of the sources is done and the form of mixture. The architecture was performed on DSD100 data. So these are the comparative analysis. We have compared various methods. The first one of 2D Fourier transform, the data set used and the result obtained in that. The speaker representation loss method, the data set obtained and the results in that. SD dense unit method, the multi-level DNN method, the CNN method. The fifth one is the method which we have used, convolution neural network method. Then the speech partition method, PIT method, testnet, that is time domain audio separation network, monoreal source separation, and the masking based baseline separation, ORPIC method, single channel source separation, the audio computational audio scene analysis, then the PESQ method, neurostring music method, parallel stacked RLS network method, and multitask learning. So the table describes the CNN, various CNN values, the DNN values. So like comparing this all, the CNN based to DNN and other methods was very very comprised, accurate and precise result was obtained. It consists of almost 97% accuracy in the output. From this evaluation, we can conclude that the best way of detecting and altered copy of an audio from a large collection of audio in a database, and how effectively we can do the music separation. So in the methodology, it is a type of deep learning processing data. CNN is a mathematical construct that is typically composed of 3 layers. It consists of 3 layers, that is convolution, polling, and fully connected layers. The first two, convolution and polling, perform the feature extraction, whereas the third maps the extracted feature into the final output. The convolution layer plays a key role in CNN, which is composed of the stack of mathematical operation. So the pixel values are stored in two-dimensional grid in an array, and a small grid of parameters called as a kernel or optimized feature is applied to the image position. As one layer feeds output into the next layer, extracted features can hereditary and progressively become more complex. The process of optimizing parameters such as kernel is called as the training, which is performed so as to minimize the difference between the output and ground. Through an optimized algorithms called backpropagation and gradient descent, among others. So this is the figure. The first is source, then convolution, pooling, flattened rest, and neural network is performed, and we get an output. This shows the figure shows an overall view of all the layers. The model's performance under particular kernels and weight is calculated through the forward propagation on a training data set and learning parameters, to the loss value through the backpropagation with gradient descent optimization algorithm. The conclusion, many methodologies have evolved in the singing voice separation method. Many parameters are taken into consideration. There are many successful methods. In this paper, the idea of a monoreal music source separation that includes a deep convolution method. As opposed to other method, the method tries to focuses on both the musical instrument and the background instrument use. The main advantage is that takes reference from the above and below values before forwarding it. It also has some disadvantages, that is works as slower because of the marks pool. It requires large data set, which can be overcome in the future work. The presenting idea, however, can produce very efficient and superior results. These are the references. Thank you.
Yeah, Renuka.
Yes, ma'am.
So can we do it for live music, or should be on for recorded only?
Yes, ma'am. Like as of now, I'm using the data set in it, which is already recorded with me, so I can do on that.
And you have compared CNN with DNN also.
Yes, ma'am.
Percentage you have achieved?
Ma'am,
Enhanced, improved, you can say.
Yes, ma'am. Compared to DNN, the CNN method is very useful. Like 3 to 4% precise output we are getting by CNN method compared to the DNN method.
So, do you think that CNN method was not used by any other person?
Yes, ma'am. I have taken the basis of one paper.
So they might have also achieved the accuracy.
Yes, ma'am.
So from the paper or the authors, those who have used CNN.
Yes, ma'am.
Have you compared your accuracy with that paper?
Yes, ma'am. I have compared.
Okay. So how much again improvement you have achieved?
Ma'am, like normal authors means which I have seen that they were getting 94 to 95%, but my accuracy was 97%.
So the again question comes, how your methodology was different from the paper, those who have used CNN, and how you have improved 3 to 4%.
Okay. When the paper means they concentrated on only separating the musical instrument like the guitar sound, the bass sound, etc. But I have also tried to collect the background noise. There is also some noise when it comes. So I have tried to capture the noise and also separate it.
Okay, thank you. Thank you, Renuka.
Thank you, ma'am.
Thank you for the great presentation, and I'm now moving forward our next presentation. Manu Rajan Nair, and he is presenting on Prophet, a tool for prediction of profits losses in bacterial genomics. You may please start your presentation.
Okay. Good afternoon, all. Let me share my screen, sir. Okay. I'm Dr. Manu Rajan Nair. I have done my research under Dr. T. Amuda, Associate Professor, Department of Computer Applications, Bharatiya University. And my journal title name is Prophetess, an implementation of prophage lossy predictor for bacterial genomes algorithm. This is the contents, introduction, literature review, research objectives, research methodology, result. The introduction part, the bioinformatics is the information science that deals with the application of computational techniques to analyze and understand biological systems. The study of genomes is a major subfield of bioinformatics. So a genome is a genome of an organism is a full set of genomic information that is present in the cell molecules such as DNA and all its variants. This genomic information is unique for each species of organisms, but individuals in a species may show slight differences among themselves, but related species may show similarities between them. This is a literature review, list of standalone lossy prediction technique tools, list of standalone lossy prediction tools, FISP, Prophet, Phage Finder, and Profinder. These are research objectives. Overall objectives are the review existing tools used in profile lossy prediction, design and develop a unique lossy predictor algorithm, design and develop a standalone tool for profile lossy prediction using LPA, the optimize the performance using PSO, and the develop metric for and compare this tool to other tools of its class. And objectives of the Prophetess standalone tool: command line interface for inputting commands, textual debug console and log file, input file in FASTA format, simple comma separated file, base table system for storing patterns as tables, output prediction file, both row prediction and the post PSO optimized prediction, evaluation mode for performance evaluation, and the research methodology. The Prophetess tool was developed in Rust programming language, and the ISE, ideal sequence encoding, was developed in Python. The core of this tool is lossy predictor algorithm. It is written in Rust, and this tool is a standalone, which is meant to run on desktop class system without high-end modes. And the LPA operates in two modes, that is training mode and the prediction mode. Both modes share a common two files, ISE file and the nucleotide sequence hash table. The training mode ends with the generation of nucleotide sequence hash table from the training dataset, and the prediction mode starts with the trained NSH hash and ends with the generation of the prediction file for bacterial sequence that is being analyzed. This is a Prophetess modules. There is an input as host and phage genomes. Then comes a pre-preparation modules, training module, prediction module, post-processing module, evaluate module. And the side is a batch training module, batch prediction module, annotated prophages, batch evaluation module. This is a LP algorithm modules. Host sequences and phage sequences are filtered and they are fed to the NSH hash encoder. This is the ISE table generator, which generates ISE table. And then the host sequences and phage sequences are fed to the training mode. And this host sequences alone, after NSH hash nucleotide sequence hashing, fed to the prediction mode, and we get the final prediction. And from this training mode, we get the final NSH hash table. After that, after the final prediction, the low side decoder gives a final prediction in CSV format. This is a training mode. Input is 30 bacteria hosts and 30 bacteriophages. Here, HTS files, PTS files, distribution generator, classifier, NSH hash table. Here is a figure of the classifier NSH hash table builder. It contains hash code, phage class, host class, common class, and then uncommon class. And this is a host set. This is a phage set of genomes, and the prediction mode also. This is a input is a novel bacterial genomes, NHS hash table, and first is a raw prediction stage, then the raw prediction file. Then after that, using PSO, fine-tune prediction stage, and the final prediction file is generated. And here, the fine-tune prediction stage of PSO is using PSO is given here. The modules are preparatory stage, raw prediction stage. After that, 5 runs are enumerated. Then densification is dense of 5 runs, PSO, and the result right and the consolidation stages come. This is a baseline testing set. And this is a result. This is a Prophetess standalone tool, performed well in high levels of sensitivity with middle PPV values. But inverse canals, it was accurate up to only 52% of this time. It was correct up to a 72% of the time in extreme conditions. Then the middling PPV range approximately 41.0 to 61.50 that it had missed locating prophages. This tool finished training with a corpus of 60 organisms in 30 minutes, but a feat with other tools that took several hours to achieve. So from an efficient point of view, Prophetess was able to achieve good accuracy without using only a fraction of time space resource of other tools. This is a baseline testing. This is a comparing with other tools, tool sensitivity and the PPV values. FISP profiler Prophet, and the Prophet is baseline testing, and Prophet is in blind gave these values comparison with other tools. And the processing time is here: bacteria, host, processing, total processing time, average processing time of training phase for 60 organisms and 30 hosts plus 30 phages. And there's a screenshot of the Prophetess tool. And this is also the screenshot of the Prophetess tool. And this comes to the conclusion. Genomic analysis is a major implementation area of bioinformatics. Genome sequence has been industrialized at large scales. There's need for computation tools that keep us with the growth without incurring high cost of processing. Modern high-end programming languages like Rust provides opportunities to develop complex but high efficient tools like this. Prophetess was a standalone tool and can provide researchers with a high accurate tool that can run on machines. The LPA can also be used to high-end online processing system for raw sequence of data. Thank you. Queries, please.
Okay, hello, Manurajan.
Yes, okay.
Yeah. Whether these genomes are you going to check later on, or you are going to predict?
No, here the prediction is there.
Okay, prediction. So what are the parameters? Yeah, what are the parameters you are going to consider? Means mainly, on which? Okay.
Mainly the parameters, metadata. We are not using many metadata. We are just using the nucleotide. We have a raw sequence has been taken, and the nucleotide sequence hashing is done, and also this ISC table is being done. ISC table is being generated.
Okay, at which stages you are going to check for genome?
At first, the training phase is done. At first, the training phase, then comes a testing phase, then comes the evaluation module is there. In LP algorithm, that evaluation module is not there. Or in Prophase tool, it comes the evaluation module. So implementation. LP is the algorithm, and Prophetess is the tool is the implementation.
Okay, okay. Thank you so much.
Okay. Thank you. Thank you.
Thank you for the great presentation.
Okay.
Now I would like to invite our next presenter, Alicia Vinod, and she's presenting on modulation techniques for visible light communication
comparative study of DPSK, QPSK, and 16QAM. Dear presenter, you may please start your presentation.
Thank you. Am I audible?
Yes. Yeah.
So I'm Alicia Vinod, and I'm going to be talking to you about the modulation techniques for visible light communication. So this is a comparative study of DPSK, QPSK, and 16QAM. So the problem statement is the design of a visible light communication system using Wi-Fi technology. So we all know that everyone around the world uses Wi-Fi these days. And because of the excessive use, the RF bandwidth is getting overused and it is saturated. So we need to come up with an alternative technology that can serve the same purpose of Wi-Fi. So that's where Wi-Fi comes in. So the visible light communication is the most promising wireless solution because it uses the LEDs for dual purpose, that is both for illumination and for wireless communication purpose. So the study focuses on the comparison of advanced modulation schemes such as DPSK, QPSK, and 16QAM. So we have done the analysis using a software called the OptiSystem software, which is an optical software that simulates wireless communication models. And the technical specifications for the optical source is taken as a frequency of 650 nanometer and a transmitting power of 0 decibel meter. So LEDs are used as the transmitter in this communication system, and photodiodes are used as the receivers. And between the transmitter and the receiver is an OWC channel, which is used as the link between the transmitter and the receiver. So let's move on to the block diagram. So this is what the block diagram of a visible light communication system looks like. It consists of a bit sequence generator, and we feed a bit sequence into this generator, and these bits are encoded by a differential encoder. The encoded signal is then passed on to an NZ modulator, and the modulated transmitting signal is passed through an OWC channel. And at the receiving end of the channel, there is a photo detector which will detect the incoming light signals, and the received signal is also passed through a filter so as to get rid of any noise, and the final optical output is passed through a bit error rate analyzer so that we can observe the error rate and many different parameters in the system. So this is what the block diagram and opti system looks like. So this is for the DPSK scheme, differential phase shift gain. So this diagram shows an optical DPSK transmitter and an optical DPSK receiver, which is connected together by an OWC channel. Similarly, we've done the same thing for 16QAM and QPSK. So the only difference in the three schemes is the internal configuration of the transmitter and the receiver. So that is it for the block diagrams. Now let's see the results we've obtained. So basically, we wanted to compare the results that we were getting from all these three schemes. So for this, we have plotted the graphs using by adding all the values in an Excel sheet. So we can compare how the system is working for the different modulation schemes. So the first performance parameter we compared is the distance between the transmitter and the receiver. So we varied the distance between 1 meters and 20 meters. And we found that 16 QAM gave the highest bit error rate, followed by QPSK, followed by DPSK. And the second parameter we varied is the bit rate. So we varied the bit rate from we varied from 1 Gbps to 10 Gbps. And in the second scenario, we varied it from 1 Mbps to 100 Mbps. So in both these cases, we were able to observe that 16 QAM showed the highest bit rate, followed by QPSK and DPSK. So the third parameter is the receiver angle. So when the LED is transmitting light, like from a distance, the light tends to diverge from the source. So as a result, the receiving angle increases. So we have varied again we varied the distance from 1 meter to 10 meter, and we have simulated the system for different receiver angles all the way from 0 microradian to 60 microradian. So these are the results we've got. So this is for 16 QM. So we've noticed that when we increase the receiver angle, obviously there is a more error rate. So we get a higher bit error rate for increasing receiver angles. And also the power decreases when we increase the receiver angle. So we get similar results for all three cases. 16 QAM, QPSK, and DPSK. So what we were able to conclude from all this analysis and graphs is that DPSK gives the least bit error rate, followed by QPSK, and 16 QAM always gave the highest bit error. And while varying the bit rate or the data rate, the bit error rate was again lowest for DPSK. And also while varying the receiver angle, the bit error rate increased with the increase in receiver angle, and the total power is decreasing. So what we were able to understand from this is that we need to choose the scheme according to our use case. So if our use case is minimal error, we want to get rid of as much error as possible, we must go with DPSK. But if we want a higher data rate, then we should go with a scheme like 16 QAM. So we should be able to tolerate the error because we want that high amount of data rate. So that is it. That marks the end of my presentation. Thank you for listening. Hope you enjoyed the presentation.
Okay, Alisha.
Yes.
Okay, for this DPSK, QPSK, or the third which you have mentioned, 16 QPSK, use Li-Fi?
Yeah, we have used optical channel.
Okay. So is actually Li-Fi available?
No, it is still under research. It is not widely used as of now because of the challenges. So I think in the future, if we are able to develop something, it will give immense data rates and will be very useful.
So is this, you can say, a Li-Fi is faster than Wi-Fi?
Yes, it provides higher data.
Higher rate.
Yes.
And we know the cons of Wi-Fi also. So if we
Yes.
compare Wi-Fi with Li-Fi in terms of cons, which one will be better?
Li-Fi provides security also. The communication is very secure. So
you mean to
Li-Fi
say
is
in
better than
Wi-Fi
that.
communication is not secure?
It is less secure. Li-Fi provides more security.
Okay, right now 5G
because it
is,
cannot travel through walls. So it provides more security in that sense.
but that will be the limitation, na, then?
Yes,
If the transmission is not happening through the walls, that will be the limitation.
Yes. So it comes with the limitation that you can only use it in an indoor room environment.
That has nothing to do with the security, right?
Yes.
Okay, one more question is 5G a Li-Fi?
Right now, it's not implemented. Right now, it is Wi-Fi itself.
Okay, thank you. Thank you.
Thank you.
Okay, thank you for the presentation. Our next presenter is Sharayu Guhe, and she's presenting on comparison between YOLO V5 and SSD for pavement crack detection.
Yeah, good afternoon. I'll just share my screen.
Good afternoon, everyone. This is Ashita Soti, and I have Sharayu Guhe, Athar Durakkar, and Shashikant Singh here with me. All the authors will be presenting today, and we are from MIT WPU Pune. The topic for our presentation today is comparison between YOLO V5 and SSD for pavement crack detection. And this is a survey paper that we wrote during the research of our final year project. I will be starting with the introduction. So pavement crack is the fundamental sign of safety in the framework. Cracks are found in all parts of the system due to environment conditions like sun, environment, fierce breeze, tsunami, shudders, and human conditions like the reliable usage of things, bad quality of material, etc. In case these parts are found in the city, by then it very well may be incredibly risky for individuals considering the way that the road orchestrate expects an essential part in the development of the country. Road network give the best situation on a scale of monetary issues by giving a line of work and loosening up of business areas. It moreover gives workplaces transportation for the people and the products. The business transportation of the items and explorers inside India use road for transportation ends up being a very typical medium constantly. Parts in road come in view of energy center point piles of the vehicle, bad quality of material used, regular and climatic conditions. With the progress in the advancement, modernized structures were made for the help of roads. These frameworks help in perceiving cracks in the roads and moreover help in figuring the boundaries like split width, the length, shape, and power, etc. These structures put away less of an ideal opportunity for help of roads and moreover give especially careful and capable results. Crack detection can also be done via trading image processing, and a programmed assessment. A high definition camera is required to photograph such structures, since the outcome in the result is entirely dependent on the representation status and visible gap. Morphical approach, edge detection trajectories algorithm, neural networks, statistical proposition, and segmentation are the procedures that have been concentrated on until now in the literature. For simple monitoring, software such as image processing, lab, OpenCV, and MATLAB graphical UI can be constructed. It additionally facilitates instantaneous monitoring from which information can be retrieved.
So as we can see in this, we have gone through a few papers. So by that literature review, we can get that the image processing methods and the encryptions applied to mostly the engineering structures for detection of the cracks. So YOLO has been ruling its area, and for most of the significant methods that we could see was one of them being used. YOLO V5 and the other being SST. And one of the papers was published in the month of May in 2020. And one of the papers also had YOLO V4 that was created by the conventional creators, Joseph Redmond and Alexei, and the other being the newly delivered YOLO V5 by Glenn Joster.
So Glenn Jocher was not a usual creator of the yellow. So his launch was encountered with some disagreement as he was not a conventional presenter, and yet avoiding past it, the V5 model has indicated a significant increment in conduct from its forerunner. So it was much better than the previous versions. YOLO V5 had heaps of benefits in this field. The exceptionally liked substitute being the utilization of Python language rather than C as it is as in its past variants. So that makes the installation and integration of with IoT gadgets very much simpler. Moreover, PyTorch community is additionally bigger than the darknet community, and that implies that PyTorch will get more contribution and has an extraordinary development potential in the future. I'll go with the methodology. So for YOLO, so it is an object detection technique that splits images into a grid system. Each and every part of the grid is in charge of detecting the objects within itself. So the YOLO version 5, it was released by Ultralytics in June 2020 and is currently the most exceptional and object recognition algorithm accessible. It is a novel CNN that recognizes objects in real time with extraordinary precision. And this is a model diagram that we can show. So you can see there is so you can see there is an input and there are fully connected layers. And the next slide. So for SSD, this technique is remarkably quicker in pace and has high precision in object identification. As you all know, SSD is submitted by Google, it is presented by Google. So SSD utilizing comparatively low resolution images, it is because it's consistent, it consists an incrementally low complex filter for predicting item class and nullifies in bounding box areas. High detection precision in SSD is accomplished by utilizing multiple boxes or filters with distinct scale and aspect ratios for object detection. So it also solicits these boxes to multiple characteristic tags from the overdue levels of a network. So this uses the identification at multiple scales. Also, SSD algorithm was constructed in a way that it may very well be correlated with different methods like YOLO, then MobileNet, or VGG architecture.
So for the first system overview, we can see that YOLO V5 detection is an effortless regression problem, which takes an image as an input and gains its understanding of a group of probabilities with a bounding box synchronization. So these are like put into a framework, and each framework participants with n number of bounding boxes along with some trust. So the total number of boxes are then predicted, and then again the greater part of these boxes have lesser trust scores. And then assuming that we can arrange the doorstep of approximately 30% of this trust, we can dispose a large portion from it. And for single shot detector, SSD runs with a complex network. So it then figures a feature map, and then we perform a little 3x3 complex size kernels and then form a feature map to anticipate the bounding boxes and classification possibility. Then SSD likewise makes the use of anchor boxes and a variety of feature ratio like faster with RCNN and gains understanding of the offset, somewhat learning the box. And to hold the level, SSD calculates the bounding boxes of the various complex layers.
So to conclude, this paper gives the overview various crack detection and classification techniques. All those techniques are thoroughly discussed and compared on various parameters. As far as we have seen in this comparative study, we have concluded that SSD, that is single shot detector method, is better than YOLO V5 since it detects low resolution images too, and it has a precision and it is faster than YOLO V5. All the parameters match the needs of our project, to the project that we were doing for our final year project, and so we choose to go with the single shot detector method for payment gratification. So these are our references. Thank you.
Sharayu?
Yes, ma'am.
Yeah. SSD uses which network?
As in?
Which network is used by SSD?
CNN.
CNN?
Yeah.
Is it? Okay, if the object size is tiny, will the SSD work?
If the object size is tiny.
Yes.
Yeah, so basically this SSD is used for like better in terms of YOLO because it detects like low precision image also. So if it is, yeah, it might detect.
Okay, okay, okay. Thank you.
Thank you.
I think so. We have completed our all presentation of this session. Now I sincerely thank our authors for their excellent presentation and great contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough, and we, on behalf of whole team, thank you for your support during this version and the previous 6 version of the conference. We will be happy to have you all in the 8th version of the conference in 2023. All the presenters will be getting the digital certificates through email within 2 working days. Further, all the papers have been already forwarded to the Springer, and the publication will be live within 5 to 6 months. So kindly cooperate with the team ICT4SD 2022. And I also thank our session chair for chairing the session. And there is one token of appreciation to be the chair on behalf of team ICT4SD and the Global Knowledge Research Foundation.
Okay, thank you so much, Harsh, and thank you so much for my nice introduction at the start of this session. Thank you so much for giving opportunity to be a session chair. And I would like to congratulate all the participants as their papers are getting published in the Springer. And I wish all them, I wish best of luck to all. Thank you so much.
Thank you once again, ma'am. And now I'd like to request you all to turn on your camera to capture the quick snapshot and make this conference more memorable. Thank you all. And thanks once again, ma'am.
Thank you so much.